So, hello everyone, welcome to Das Lake. This is lecture number 3 of the 1000 question series, and currently we are dealing with the subject heat transfer, and the part is conduction. This is the part 3 of conduction. So, if you have missed any part, so you may check it out on the YouTube. Okay, so let's move to the first question. This is the first question. A cube shaped solid 20 cm side having density of 2500 kg per meter cube and specific heat of 0.52 kilojoule per kg Kelvin has a uniform heat generation rate of 100 kilowatt per meter cube. If heat received over its surface is 240 watt, the rate of change of the temperature of the solid. Okay, so this is the question of conservation of energy. Okay, so what is conservation of energy? Okay, this is, let's suppose this is any body. Okay, this is any body A. So let's suppose some heat is coming to it. Okay, that is, let's suppose, energy in. Okay, we're talking in a rate, so energy in dot. So, and some heat is going out of the surface. Let's suppose that is E out. Okay, and some heat is let's suppose being generated in the surface. Okay, in the body. So this is E generation. Okay, if I will write E in minus E out, okay, plus E generation, okay, then that will be equal to E stored. Okay, if we'll talk in red form, then dot and dot. Okay, this is the net amount of energy that is coming into the system. Okay, the amount of energy that has came minus the amount of energy that has gone out of the system. So this is the net amount of energy that has came into the system. Okay, and this is the amount of energy that has been generated in the system. So this is the total energy that has been stored in the system. Okay, so in the question it has been said that uh, if heat received over its surface is 240 watt. Okay, so the net E in minus E out is 240. Okay, so here I am writing E in, E dot in minus E dot out plus E dot generation is equal to E dot stored. Okay. So this amount is given in the question, that is 240 watt. Okay, plus, okay, and uh, uniform heat generation. Okay, uniform heat generation rate of 100 kilowatt per meter cube. Okay, so what is the rate of heat generation then? 100 kilowatt into the volume. Okay, is equal to, sorry, it is in kilowatt and it is in watt, so I will have to multiply 1000 also here, because this one is in watt and this one is in kilowatt. So make uniformity of the units, I need to multiply 1000 with the 100. Okay, 100 kilowatt is equal to 100,000 watt. so is equal to E stored. Okay, what is the rate of energy stored? Okay, that will be m dot Cp. Okay, d. Okay, this is not m dot. Let's suppose that because it is a constant mass system, so m Cp dt divided by d time. Okay, because this is in watt. Watt means energy per unit time. This is also in watt, energy per unit time. So I also need to write it here in watt. So mcp dt is energy divided by dt is in watt. Okay, so here what I need to find out is this. What I need to find out, the rate of change of temperature of solid with respect to time. Okay, so I need to find out this term. So my answer will be 240 plus 100 into 1000 into the volume. What is the volume? Volume is 20 cm. Okay, 20 cm is the length of the cube, so the volume will be 0 0.20 cube. Okay, divided by mcp. Okay, what is m? M is density into volume. So density is given, that is 2500 into volume. Volume is 0.2 cube. Okay, this is m. Now the cp is 0.52 kilojoule. So I need to write it in joule. So it will be 520. So my answer is dt by d small t. So by solving this, I will get okay dt divided by d small t will be equal to 0.1 okay Kelvin per second, or degree Celsius per second. So the option A is my answer. Now let's move to the next question. So this is my second question. A cylindrical uranium fuel rod of radius 5 mm in a nuclear reactor is generating heat at the rate of 4 into 10 to the power 7 watt per meter cube. The rod is cooled by a liquid convective heat transfer coefficient 1000 watt per meter square Kelvin at 25 degrees Celsius. Okay, at steady state, okay, the surface temperature of the rod. So this is one important data that is given, that is steady state. Okay, if steady state is given, then del T by d small t will be is equal to 0. Why? Because steady state all the properties are constant, so the temperature, change of temperature with respect to time will be 0. If this is equal to 0, then energy stored rate will also be equal to 0. So whatever E in minus E out, okay, it will be equal to, or I can say plus E generation, okay, is equal to 0. So this one, okay, is given in the question. Okay, this. So E in minus E out. Okay, E in minus E out. Let's suppose what is given in the question. Let me draw. Okay, so let's suppose this is a rod, or this is a rod. Okay, and it is surrounded by a fluid. of convective heat transfer coefficient H, okay, and it has a temperature of T infinity, and let the rod has a steady state temperature of Ts. So E in minus E out, okay, plus E generation will be equal to 0 or not? Yes. So E in minus E out, E in is 0, okay. The as the temperature of solid is greater than this, so no heat will come here, but heat will come out from the body to the fluid, okay. So it will be only E out, so minus, okay, minus E out, okay, this is 0, minus E out. E out is H of body into AS of body into Ts surface temperature minus T infinity, plus E generation is equal to 0. Yes or no? So now H is given 1000, okay. Area is the surface area. The surface area is pi dl, okay. So pi into d is radius is 5 mm, so diameter is 0.010, okay, into L, okay, into Ts. Ts is, we need to find out, T infinity is given. T infinity is 25 degrees Celsius. So yes, 25 plus E generation. E generation, okay, it is given per unit volume. So we need to multiply 4 into 10 to the power 7 into volume. What is the volume? Volume will be what? Pi r square h, volume of the cylinder. Yes or no? Yes. So pi r, okay, pi by 4 d square h, 0.01 square into h is L, okay. So from both the sides, let's cancel out some terms. So it is not visible. Yes, it is a little bit visible, okay. Pi and pi gone, okay. 0.01 with 0.1 power it will take, L will go on with this, okay. So now if we will solve, there is only one unknown, okay. There is only one, yes, we can find out from here, okay. Here there is a minus sign, I have forgot to mention here, okay. Here it is minus, okay, this minus sign, okay, and it is equal to 0, okay. I have cancelled out the term, so okay, let me make one thing, okay. Forget this minus sign, okay, as I cancel out the terms. So it will be equal to, it will, if I will replace this, yes, if I'll make this equal to, then the expression will be correct, okay. Well, see, this minus will go to this side, then it will be plus, so this is the term and this is this term. So okay, from here Ts is 125 degree Celsius, but it has been asked in Kelvin, So I need to add plus 273 and it will give me 398 Kelvin. Option B. So now let's move to the next question. Okay, so this is our next question. A fin has 5 mm diameter and 100 mm length. The thermal conductivity of the material is maintained at 400 watt per meter Kelvin. One end of the fin is maintained at 130 degrees Celsius. Its remaining surface is exposed to ambient air at 30 degree Celsius. The convective heat transfer coefficient is 40 with the heat loss from the fin. Okay, so let me draw the figure first. Okay, this is one of my surface. Okay, and this is the base of my fin, and this is the outer end of my fin. Okay, the K value is given for fin and H is given for this fluid. Okay, so if you look at the question carefully, it has not mentioned any boundary condition. Okay, any boundary condition for this end. So I will take it that convection is happening at this end. So for this question, I need to find out the corrective length first. So what is the corrective length? The corrective length LC is equal to L plus AC cross sectional area divided by the perimeter. Okay, so L is 100 mm plus cross sectional area 5 mm diameter, so pi by 4 d square 5 square. Okay, pi by 4 5 square into by okay by pi d, pi into d. Okay, this is my corrected length, so it will come around 101.25. Okay, this is my corrected length. So now this question has been converted into the insulated tiffin question. Okay, now if I will replace this LC in place of L, my question will convert into the insulated tiffin question. Okay, so the what has been asked, the heat loss. Okay, the heat loss. So the heat loss will be Q is equal to root over of HPKAC. Okay, this is the formula for heat loss, theta B into tan hyperbolic MLC. Okay, now I need to find out the M first. Okay, everything is given, but I need to find out this M first. So okay, let it be here only. So M is root over of HP by KAC. Yes or no? Yes. So h value is 40. Okay, p pi into d. Now I need to put it in mm. Okay, d, that is 5 mm, 0.005. Okay, divided by k. K is 400 AC, pi by 4 d square, 0.005 square. So my m value will come 8.944. Okay, now I'll find out the q. So q will be root over of hpkc. H is 40, p is pi into 0.005, k is 400, AC is pi by 4 d square, that is 0.005 square. Okay, this is this term I have written. Now theta b, is, okay, theta b is tb minus t infinity. The tb is given, that is 130, and t infinity is 30. So tb minus t infinity, that is theta b, is 100. Okay, into tan hyperbolic. Okay, m value I have found out, that is 8.94. Okay, here 8.94 into lc. lc is 101.25 mm, which is in meter, is 0.101. Okay, this much is enough. So if I'll find out this expression, my answer will be 5.04. Okay, so option B. So now let's move to the next question. So this is an interesting question. Two rods, one of length L and other of length 2L, are made of same material and have the same diameter. The two ends of the longer rod are maintained at 100 degrees Celsius. One end of the shorter rod is maintained at 100 degrees Celsius while the outer end is insulated. Both the rods are exposed to the same environment at 40 degrees Celsius. Okay, the temperature at the insulated end of the shorter rod is to be 55 degrees Celsius. The temperature at the midpoint of the longer rod. Okay. So here, okay, let me draw it first. So So this one is my longer rod, okay, and this one is my shorter rod, okay. The longer rod has two ends fixed, okay, these are fixed ends, and both of them are at 100 degree Celsius. So for the short end, sorry, short rod, this end, okay, this end is insulated. So the short rod will act as an insulated tip fin. Yes or no? Yes. So if I'll write the expression for the short rod, okay, for the insulated tip fin, okay, if I'll write the expression for temperature, the theta, okay, that is T minus T infinity, theta x theta b, it is for the insulated tip fin is cos hyperbolic m L minus x divided by cos hyperbolic ml. Okay, so one observation it has been made that the insulated end of the shorter rod is at 55 degrees Celsius. So if I'll put theta is equal to L, okay, divided by theta b, okay, so theta is equal to L is 55 degrees Celsius, T is equal to L is 55 degrees Celsius, so theta is equal to L at L is equal to 15 degrees Celsius, 55 minus 40, okay. Now theta b is 100 minus 40, that is 60, is equal to, okay, cos hyperbolic. Now I have put x is equal to L, so L minus L will be, okay, this L minus L will be 0, so cos hyperbolic m into 0 is 0, cos hyperbolic 0 divided by cos hyperbolic ml, okay, cos hyperbolic 0 is 1 divided by cos hyperbolic ml. So from here I can find out the value of cos hyperbolic ml, that is equal to 15 4 4, yes or no? So cos hyperbolic ml is equal to 4. I will use it later. Now for the bigger rod, if you see for the bigger rod, the two ends are maintained at two temperatures, okay, that could be same but two ends are maintained at two temperatures, okay. So for that we have an expression, okay, if two ends are maintained at two temperatures, then theta at x by theta at b, okay, is equal to theta L divided by theta b divided by, okay, sorry, not divided by, whole divided, it will come, okay, I'll use that later, sine hyperbolic mx, okay, plus sine hyperbolic, okay, m, okay, L minus x divided by sine hyperbolic ml. But this expression is basically for a rod whose length is 2L, sorry, L, but my the bigger rod's length is 2L. Okay, this length is 2L. So in this expression I need to put, okay, I need to put 2L in place of L. So this is, okay, this one I have to do 2L, and this one is also 2L. Okay, now, and this one is also 2L. Now if I will put x is equal to 2L, okay, if I will put x is equal to 2L divided by theta b, okay, it will be equal to theta 2L. What is theta 2L? Okay, what is theta 2L? See, here also the temperature is 100 and here also the temperature is 100. So this is base plane, this is 2L plane. So theta b is equal to 100 minus 40, that is 60, and theta 2L also 100 minus 40, that is 60. Okay, so these both are equal, that is 1. Okay, I got it. Now I have just said that this term is 1 theta 2L by theta b, so this 1 into sine hyperbolic m into 2L, sine hyperbolic m into 2L, because my x is 2L now, plus sine hyperbolic m into 2L minus x. X is 2L, 2L minus 2L is 0, so this is 0. M into 0, 0. Sine hyperbolic 0 is 0 divided by, okay, we have done a mistake. What mistake? Okay, we need to find out the temperature at this section, mid section. So why we are putting x is equal to 2L? So first let us rectify this one. Okay, this we don't need to do. No, I'm sorry, I'm really sorry. Okay, now let's do. Okay, let's do it. Now I will put theta x is equal to L divided by theta of b. Okay, this term is 1, theta 2L by theta b is 1, as I have said just before, into sine now hyperbolic ml, sine hyperbolic ml, okay, plus again sine hyperbolic m into 2L minus x, 2L minus x, so 2L minus x, x is L, so sine hyperbolic ml, yes or no? Yes, divided by sine hyperbolic m into 2ml, okay, m into 2L, that is 2ml. Okay, so now what is theta b? Okay, let us make it this like TL minus T infinity. T infinity is 40 divided by T. What is theta b? That is 100 minus 40, 60. is equal to, okay, see here, this is sine hyperbolic ml plus sine hyperbolic ml. This means 2 sine hyperbolic ml divided by sine hyperbolic of 2 ml. So this is 2 sine hyperbolic ml into cos hyperbolic ml. Yes or no? So this gone. Okay, this is equal to 1 divided by cos hyperbolic ml. So my TL minus 40 divided by 60 is equal to 1 divided by cos hyperbolic ml, and I have found out cos hyperbolic ml as 4. So I will use that cos hyperbolic ml as 4, and it is 1 by 4. Okay, so from here I need to find out the temperature TL. TL is equal to 60 will be gone here, 60 divided by 4, then 40 will be added here, plus 40, so that is 55 degree Celsius. Option C. So this is the answer. Now let's move to the next question. So this is our question. A steel rod of 12 mm in diameter and 60 mm long with an insulated end is to be used as a spine. Okay, spine means fin only. It is exposed, okay, insulated end. Boundary condition is given here, insulated end. It is exposed to surrounding with a temperature of 60 degrees Celsius, T infinity, and a heat transfer coefficient of 55 H. For this fin, the efficiency is found to be 62.18%, the effectiveness of the fin. Okay. For insulated T fin, okay, for insulated T fin, okay, the efficiency will be, okay, efficiency will be 1 by ml tan inverse H, okay, tan hyperbolic, sorry, I really apologize, tan, not tan inverse, tan hyperbolic ml. Okay, so what is m? M is, we have used this question m from previous, that is HP divided by KAC. So what is H? H is, okay, H is this one, transfer coefficient 55. P, what is P? P is pi d, okay, pi into d, that is 0.012 divided by KAC, okay, KAC. K is basically not given, okay, I will assume it is K. AC is pi by 4, okay, pi by 4 d square, d is 0.012 square, okay, this is my m, okay. But now see, efficiency is given as 62.18%. So my efficiency, okay, 62.18%, means it is equal to 0.6218. Okay, so this expression, okay, this expression has L we know, okay, L we know, M is the only thing that we need to find out. So let's find out M from here first. Okay, so if I will take what 1 second. Okay, I need to find out M, but I think it is a difficult method to find out. Okay, now let me show you one short trick. So if you go conceptually, what is efficiency? Efficiency is Q fin divided by Q fin max. Yes or no? Yes. What is effectiveness? Effectiveness is Q fin divided by Q without fin. Yes. Yes. If I will divide both of them, so what I will get? I will get, okay, efficiency divided by effectiveness is Q without fin divided by Q fin max. Okay, what is Q without fin? Q without fin, okay, Q without fin is basically, okay, H AC cross sectional area into theta B. And what is Q max? Q fin max, it is H AS into theta B. So from here, okay, H and H, theta B gone. So I have got direct relation between efficiency and effectiveness, that is AC divided by S. Okay, so what I got, 1 second. Okay, efficiency divided by effectiveness is AC divided by AS. Okay, now what is efficiency? Efficiency is 62.18, so it is 0.6218 divided by effectiveness. What is the cross sectional area? It will be pi by 4 into d square. What is d? D is 12 mm. 0.012 square. Okay, okay, okay. Now what is surface area? Surface area is pi dl. Pi, what is d? 0.012 into L. L is 60 mm, 0.06. Okay, from here I can directly find out the effectiveness. Okay, from here the effectiveness is 12.436. So this is my shortcut. Option D. Now let's move to the next question. So a brass rod infinitely long and 5 mm in dia extends horizontally from a casting at 200 degree Celsius. Okay, infinitely long. These are the things you should mark. Okay, and 5 mm in dia extend horizontally. Okay, casting. This means this is the TB, the best temperature. The rod is in the air environment with T infinity is 20 degrees Celsius, H is 30, and K is this. What is the fin effectiveness? So for the long fin, okay, for the long fin, the effectiveness is root over of Kp divided by HAC. Okay, for the long fin, or infinitely long is given. Okay. Now, so I need to find out this term. So under root, what is K? 133. What is P? Pi D. Pi D, that is 0.005. Okay, pi D. H is 30. HC pi by 4. Okay, D square 0.005 square. So from here, what are being cancelled out? Pi gone with pi. 0.005 takes 1 power. Okay, now this much. So from here, my fin effectiveness has come 59.55. If I'll calculate this, option C. Now let's move to the next question. Okay, what should be necessary? Okay, this is objective question. What should be the necessary condition when Hassler chart is not required? Not this, not okay, not required. Internal conductive resistance should be 0. External convective resistance should be infinite. Internal conductive resistance should be equal to external convective resistance. Internal conductive resistance should be negligible as compared to external conductive. Okay, this one is the answer. Why? Because Biot number is internal conductive, okay, conductive resistance divided by external convective resistance. And by lump heat analysis is only applicable if Biot number is less than 0.1. So when it will come? When this term will be less than this term, or negligible less than this external convective resistance. Okay, if internal conductive resistance is negligible as compared to external convective resistance, then Biot number will come very low. So lump heat analysis can be used, and if lump heat analysis is used, so we don't need any Hassler chart. So my option is D. Now let's move to the next question. So a metal ball of diameter 60 mm is initially at 220 degrees Celsius. The ball is suddenly cooled by an air jet of 20 degrees Celsius. Okay, the heat transfer, okay, it is not here, it is heat. The heat transfer coefficient is 200 watt per meter square Kelvin. The specific heat, the thermal conductivity and density is given. This is this. The ball temperature after 90 seconds will be. Okay. So directly we can say that this is a question of unsteady conduction. Because why? It is been asked directly that what is the temperature of the ball after 90 degree. So definitely the temperature is varying. If temperature is varying, then this is a unsteady. Okay. Now let's find out the Biot number for this. Biot number. What is Biot number? Biot number is HLC divided by K of solid. Okay. So what is H? H is okay. H must have been given. H is not given. Okay, heat transfer coefficient here. H is given 200. Okay. LC, the characteristic length of the sphere, that is the diameter only. So it is not the diameter, it is, see, the characteristic length. Okay, I am showing it in the next page. The characteristic length for Biot number is volume divided by surface area. As it is a sphere, so the volume is 4 by 3 pi r cube and the surface area is 4 pi r square gone, 4 pi gone, it is r by 3. Okay, or d by 6. So LC is 60 mm dia, so L by 6, sorry, D by 6. D is 60, so 0.060 divided by 6. And K of solid is given, that is, okay, thermal conductivity is 400 into 400. So what is Biot number then? 200 gone with this is 2. So okay, whatever, definitely it will be less than 0.1. If it is less than 0.1, okay, let me find it out first. So why to do random guess? Okay, divided by 12. Okay, this is 0 point, this the value is 0.005, which is far less than 0.1. So my lump heat analysis is applicable. So by lump heat analysis, okay, what lump heat analysis gives me? It gives me the relation between temperature at any time t. So it is T minus T infinity divided by Ti, the initial temperature, minus T infinity, is equal to e to the power minus T by tau. Okay, so what is tau then? Tau is, what is tau? Tau is, okay, tau is rho v Cp divided by HAS. So what is rho? Rho is 9000 kg per meter cube. 9000. What is V? Pi by 4. So not pi by 4. 4 by 3 pi r cube. What is r? R is okay 30 mm. So r oh, r cube 0.03 cube. Okay, 4 by 3 pi r cube. Now cp is okay. cp, the specific heat. Okay, the specific heat is 400. Okay, thermal conductivity is also 400. Okay, I have taken some of the thermal conductivity as 400. Okay, the same thing. And 2, okay, 400. Okay, divided by h. H is 200. A, surface area 4 pi r square 0.003 square. So from here my tau will come as 18,000. Okay, so remember this, my tau is 18,000. I will use it here. Where? Here. This tau I have found out. So t I need to find out what is, okay, what is given, what is asked in the question. The ball temperature after 90 seconds. So let that ball temperature be T. Okay, minus T infinity. What is T infinity? T infinity is 20 degrees Celsius minus 20. What is the initial temperature of my ball? That is 220. Is equal to e to the power T. What is T? What is, oh sorry, that is 90 seconds divided by tau. Tau is 18,000. I have just found out this. Okay, from here there is only one unknown, that is T. That could be find out very easily. T is okay. One blunder has been done, that is it. See, this one, okay, this one is wrong. Why? Because it is not 0.03, this is 0.003. Okay, so the answer for tau will come as 18. So this is 18. Rest of the things are correct. So here it is 18. Okay, the answer will be 21.34. Now let's move to the next question. I am sorry, I have made another blunder. See, I have corrected the wrong thing. See, this is okay. Okay, this is okay. This is 0.03. See, let me make you completely understand. See, the diameter is 60 mm, so the radius will be 30 mm, so it is 0.03. See, so this thing I have made mistake. So this is 0.03 square. Okay, from here the answer will be tau will be 180, and if I'll put that here, okay, if I'll make it is 180, the answer will be 141.3 degree Celsius, which is given in the question. So yes, mistakes has been done. and don't repeat these mistakes in the exam. Let's do a similar kind of question. A steel ball of diameter 60 mm is initially in thermal equilibrium at 1030 degrees Celsius in a furnace. It is suddenly removed from the furnace and cooled in an ambient air at 30 degrees Celsius with convective heat transfer. This the thermophysical quantities as given. The time required in second to cool the steel ball from 1030 to 430. Okay, what was our formula? T minus T infinity divided by Ti minus T infinity is equal to e to the power minus T by tau. First thing first, I need to find out the tau. Tau is rho v Cp divided by HAS. Okay, so what is the rho? 7800. 7800. What is V? V. See, V is 4 by 3 pi r cube. Okay, and surface area is 4 pi r square. So, sorry, r square. Okay, r square gone with r cube. Okay, 4 pi gone 4. So V by AC, just remember for sphere it will be r by 3. So V by AC, okay, this term will be r by AC. What is r? 60 mm dia, so r is 30 mm. So 0.030 divided by 3. Okay, and to Cp is Cp, specific it, that is 600. Okay, H 20. Okay, yes, we have already taken. So from here tau will be 2340. Okay, see, so what I need to find out? I need to find out the time. So the final temperature is given, that is 430 degrees Celsius. 430 minus T infinity. T infinity is 30 degree. Initial temperature 1030 minus 30. Okay, is equal to E minus time I need to find out divided by tau, that is 2340. 2340. Okay, if I will take ln from both the sides, okay, we'll take log of both the sides. Ln 430 minus 30, that is 400 divided by 1030 minus 30, this is 1000. Okay, this is minus T by 2340. So if I'll take the 2340 to this side with the minus, so my time will come as 2144.120 second, which is option D. Okay, so this is for today. Hope you have enjoyed the class. If you really like the class, so hit the like button and share it among your friends, and if possible kindly subscribe the channel. Thank you.